Hi everybody. So last week we were talking about how Earth orbits the Sun on the elliptical plane. This week I wanted to talk to you about how that orbit affects our seasons. But before I start talking about how our orbit affects our seasons, I have to talk to you about albedo. Albedo is the amount of sun or energy that's being reflected from a surface. And that plays a large role in how our seasons are affected by the orbit. So what is albedo exactly? Let me show you an example. So here's the surface of planet Earth, here's the ground, and we're going to have sun coming in. So the sun's coming in and hitting the ground. Now some of these rays are going to be absorbed into the ground, and some of the rays are going to be reflected or bounced back out into space. These reflected rays is what the albedo is. It's the amount of energy being reflected back out into space. Now there are a few things that affect albedo. There's color, there's the texture of the ground, and then finally there's the angle at which the sun rays are hitting the ground. So let's talk about color first. The darker an object is, the less albedo it has. So black has the least amount of albedo because it's absorbing the most amount of light. White and lighter colors have higher albedo because it's reflecting the light. So if you've ever gone out in the middle of August and it's really sunny out and you've worn a black shirt, you've probably noticed that it's really hot. And that is because black has the lowest albedo out of all the colors. It's absorbing, look, this is not a very good shirt, but it's absorbing the most amount of sun compared to other shirts. So the sun is coming in, it's hitting the shirt, and it's being absorbed by the black shirt because it has low albedo. There might be some sun rays coming off, but the majority are going to be absorbed. Now, in comparison, if you had a shirt that's light colored, let's say this light green here, one second, light green shirt, this shirt is going to have a higher albedo than the black shirt because it's a lighter color. So the sun's going to come on, it's going to hit the shirt, and it's going to have more rays coming off the shirt because it has higher albedo, and it has higher albedo because it's a lighter shirt. In nature, this happens with snow and ice. So the ground is black, brown, it's green, and ice is just white. So ice is lighter than the dirt, grass, and all that. So ice has high albedo and the ground has low albedo, the actual dirt. So that can make a difference. The next thing I want to talk about for albedo and how it's affected is the texture of the surface that sunlight is hitting it. So if the surface is really smooth, it's going to have higher albedo. It's going to have a higher chance of reflecting the light off of the surface. Think of a mirror. Mirrors reflect light because they're so smooth. Now, if in the opposite direction, if the ground is rough, it's going to have more surface area. And the sun is going to have a better chance of being absorbed by the ground. So the ground's going to have really low albedo. It's going to be rough. While a smooth surface is going to have a high albedo. It's going to be reflecting the light off. A rough surface is going to have low albedo. It will be absorbing the light. And the last factor I want to talk about for albedo is the angle at which the sunlight hits the ground. Now this is the most important one when we're talking about the changing of seasons, because the planet's really not changing color too much when the seasons are changing, and the texture of the ground really isn't changing that much. But the angle at which the sunlight is hitting Earth does change. So for albedo, if the sun is hitting the ground perpendicularly at 90-degree angles, that's going to have low albedo. The sun is going to be being absorbed into the ground, more likely going to be absorbed. If the sun hits the ground at an angle, it's going to have higher albedo. It's going to have a higher chance of being reflected back out into space. So the flatter ground, where the sun is hitting the ground at a 90-degree angle is going to have low albedo. And where the sun hits the ground at an angle, it's going to have higher albedo. So I'm going to repeat this again because this is the most important part we're going to be talking about in class. So if the sun hits the ground at 90 degrees perpendicular to the ground, it's going to have low albedo. It's going to absorb the majority of the sun. But if it's hit at an angle, the sun rays are going to have a higher chance of being deflected off the ground and back into space. Last class we talked about how the Earth orbits around the sun, but I didn't talk about how the Earth rotates in comparison to the elliptical plane that the Earth is on. So the Earth is orbiting the sun on a flat plane in a big circle, and its rotation is not a 90-degree angle compared to that plane. So it's not like this. It's actually slightly tilted, and this tilt is the reason why we have seasons. So we have a slight tilt like this is actually a 23-degree tilt. So compared to that original tilt that I showed you, it's 23 degrees difference. And that 23 degrees gives us the seasons. That tilt creates seasons for different areas because different parts of the planet are exposed more towards the sun. So for example, where there's the 23, we'll call that the north. And we'll put a line right here dividing the planet. And so the sun is both giving more exposure, more time to the northern part of the planet, and is also hitting the planet more directly at a 90-degree angle. So there's going to be less albedo on the top. There's going to be more absorption than there is on the bottom, the south. Now it's going to be the exact opposite on the other side of the orbit. So let's say the Earth is on the other side of the orbit. So 6 months have passed. The south is going to be getting more light and is going to have a lower albedo because the sun is going to be directly hitting that side of the planet compared to the north. And we're going to be exploring this in class tomorrow. So if you're confused about this, we're going to be doing a few exercises and we will figure this out. So I'll see you guys tomorrow. Thanks for listening.